So today we're going to talk about histograms. We're going to talk about how to make them, how to interpret them, all the fun things. And so here we go. So dot plots and stem plots show every single individual data value. So when we look at a dot plot, we can see every individual data value. When we look at a stem plot, we can see every little bitty individual data value. But sometimes, especially for large data sets, that can kind of make it a little bit too detailed. And so we sometimes want a better picture by group. So we want to just kind of look at just a group of, or a section of the graph. And so we would use a histogram. So a histogram is going to show each individual as a bar. So each individual, or each interval, histogram shows each interval as a bar, and the heights show the frequencies or the relative frequency of the value in each of those intervals. So again, we're going to have sections, and then we're going to see how frequent those are. So shows each interval as a bar, and the heights of the bars show the frequencies or the relative frequencies of values. Remember, frequencies are just how many, it's just like counting it. Relative frequency is the percentage. So frequency is just counting, relative frequency is the percentage. So that's going to be our histogram. All right, so here is a dot plot on the left, and we have the histogram on the right. And so these are the duration of 220 eruptions of the Old Faithful geyser. Notice that the histogram, basically, I just take sections of the dot plot and kind of put them together, and then that's how tall the histogram bars are. So the shapes are going to end up being pretty similar, but it's just, I just now have sections of data, not just each individual little data, okay? All right, so how do I make a histogram? The first thing we're going to do is we're going to choose equal width intervals. I want to make sure that my intervals have an equal width, okay? We want 5 intervals at minimum. I don't want any less than 5 because then it's really not as helpful. So I do want 5 intervals at a minimum. Usually 10 is kind of the maximum. So we want equal widths, okay? So we don't want to go by 10s for the first 2 bars and then 5 for the next bars. We want to do equal widths the whole time. The next thing we're going to do is we're going to make a table that shows the frequency or the count or the relative frequency for each of the intervals. So we're going to find out how many values are in each of the intervals that we've come up with. Then we're going to draw and label the axes. We want to make sure we name the x variables, and then we want to make sure we say whether it's percents or counts on the y-axis. We will put the scale on each axis. We'll make sure that we put the values for each tick mark on the x, and then on the y, again on the y, what do you have to start the y-axis at? 0. The vertical axis, we want to make sure we start it at 0, and that way we're not messing up any kind of visual that it might have. And then we would draw the bars above each interval. We want to make sure that each bar has an equal width. Again, we don't want to do anything that would cause us to be making a bad representation. We don't put any gaps between the bars unless there is a gap in the data. So we would make sure that the bars touch, and then if an interval has no data values, then it's going to be a height of 0 on the graph. So, cool? All right, let's do it. let's make a histogram. So this is data about the percent of foreign-born residents in your state compared to the rest of the country. The table presents the data for all 50 states in 2018. And so we're going to make a frequency histogram to display the data. So just FYI, a frequency histogram means that on the y-axis I'm going to have frequencies, not percentages. And so the first thing we need to do is we need to find what our intervals are going to be. So we want to find the minimum and the maximum values in our data. So the minimum value is West Virginia at 1.5. The maximum value is California at 26.9. So I got to get from 1.5 to 26.9-ish. But I want to make equal intervals that are going to give me at least 5. So if I go by 5s, then I'll have at least 5 different intervals or 5 different groups, and then I'll be able to have my histogram. So we're going to basically make a table, and we're going to count how many of each of these. Now, I went ahead and just did it because that's a lot of counting or whatever, but basically we would say, okay, anything from 0 to just less than 5, so 4.9. So we would go through and we would count how many of these are 0 to just less than 5. And so obviously we would just count up how many those are. So 1, 2, you guys get that, right? Okay, we don't have to go through that. Okay, cool. So there's 14 of those. And then 5 to just less than 10, so 10.9 or 9.9, there was 19 of those. 10 to 14.9, there was 8 of those. 15 to just less than 20, so 19.9, there was 5 of those. And then 20 to 24.9, there was 3 of those. And then 25 to 29.9, there was 1 of those. So you're going to want to make sure that you have that table somewhere on your paper. That way you can see where we got the numbers that we're going to use. Okay, so, and then this is just the frequency table. Again, just showing the frequency of each interval. Yes, ma'am.
How come you're going up by 5?
Okay, so that's a great question. So to kind of put the last one together with this one, so we found that our minimum was the 1.5. And then, so 1.5, and we found that our maximum was 26.9. And so I want to make groups that get me from 1.5 to 26.9, and then I have at least 5 groups. So let's say I go, okay, well, let's go 0, 10, and then 20. And then 30. So if I did that, which we already know we're not going to, but if I did that, then look at how many groups I would have. I would have just 1 group, 2 groups, and then 3 groups. So then that's not enough, right? I want at least 5 groups together. So I go, okay, if that's not enough, then maybe I go by 5s. So I add a 5, a 15, a 25. And I go, okay, how many is that? Well, that would be 1, 2, 3, 4, 5, 6. So now I have 6 groups, which is somewhere between 5 and 10 groups. So that tells me that that's a perfect amount of groups to make. Does that make a little bit more sense, Isabelle? Mm-hmm. Okay, cool. All right, everybody have the frequency table? Perfect. Now we're going to transition to the actual histogram. So we're going to draw and label our axis. So we've got on the x-axis the percent of foreign-born residents. That's what the data was about. And then we have our number of states on the y-axis. So we're going to have, this is our frequency, is going to be on the y-axis. Again, our intervals on the x-axis, we were going by 5s. So we had from 0 to just less than 5, and then 5 to just less than 10. Now, notice, guys, that your x-axis is basically just the beginning of each of the intervals. That basically turns into your x-axis, okay? Obviously, you would never want to do this. You would never want to say 0 to less than 5, 5 to less than 10. Like, that's going to get kind of messy there. So you can just use the left side or the lowest the lowest value for each of the intervals on your x-axis. And then our number of states is going to be our frequency. I bet you can guess what we're going to do next. You just graph it. You just draw the bars. So we're going to draw the 0 to 5 bar, right? We're going to draw it at a height of 14. And then the 5 to less than 10 bar, we're going to draw it at a height of 19. And it ends up being like that. Notice that the bars do touch. That's because our data goes one value right into the next. So from 0 to 4.9 goes right into 5 to 9.9, goes right into 10 to 14.9, and it's just a seamless number line all the way down. Any questions about how to make a histogram? So, histograms are kind of fun. Yes? So I only have to go up to the number, hang on, let me go back. Beep. So why did the y-axis go up to 20 is because I only have to go up as high as my highest frequency. So my highest frequency was 19, so I just want to go just slightly higher than that. Yep. Any other questions? Cool. All right. So these are two different options that we could have done. So the graph on the left here is the one we just made, and then the graph on the right actually does the intervals as 2.5. So it's from 0 to 2.4, 2.5 to 5, 5 to whatever. Anyways, it's half of the intervals. So notice that they look a little bit different now, okay? Now you can see a little bit more of the detail, but maybe it's a little too much detail. It's a little, like, we've got like all kinds of stuff going on there. Kind of depends on what you want to use the data for. So it's kind of depends on, like, do I just want to see kind of the overall shape, or do I want the details? So the big thing here is just make sure that you understand that the interval, the more specific or small the interval is, the more detail you're going to get. The kind of the wider the interval, you're going to get a little less detail, but you're going to be able to see the overall shape a little bit better. Okay. All right, so histograms with more intervals show more detail, but they may have a less clear overall pattern. Okay, cool. So we're going to answer these questions real quick. Use the histograms to answer these questions. What percent of states have less than 10% foreign-born residents? We're going to describe the shapes of the two graphs, notate if there's any outliers, and then estimate the center and the spread of the distribution of percents of foreign-born residents in the 50 states. So I'm going to give you guys a couple minutes to do that, and then we'll talk about it. Let's see what we got. What did you guys get for your percentage?
66.
Let's see. So, 33 out of 50, or 66% of states. Very good. And what did you guys get for your shape? What did you think for the shape of this one?
Skewed to right.
This is right skew. Very good. This looks like a right foot. Okay. And then, what about this one?
Skewed right.
Also skewed right. Yes. So the skewed is the same. Now, some people would look at the one on the left and say that one's unimodal and that this one is bimodal, okay? So, true, probably, but they are both definitely right skewed, okay? So we've got, this one's talking about skewed to the right with a single peak, skewed to the right with two clear peaks, okay? So bimodal. All right, and then what about the centers? Where do you guys think the center is? This is always a tricky question with a skewed distribution. Where's the center at? What do you think? Yes?
Probably around 10%.
Okay, cool. So here's the deal. Some people, including teachers, will say that the center is whatever the center of the x-axis is. That is maybe not correct when you're looking at a skewed distribution. So on a skewed distribution, you have to think about where would this graph balance, okay? We're actually going to do an activity tomorrow that's going to talk a little bit about the balance point. And so you got to think about where would this balance. If I were to take this graph and put it on like one of those little triangular little balance things, like where would it balance? If I put it right here at 15, if I put the little triangle thing right there at 15, what's going to happen to the graph? Yeah, it's going to fall to the, if I put this little triangle thing right here, the fulcrum right there. Well, this side's going to go whoop, and it's going to fall right down. So if I think about where can I balance this, right, I would need to move this over a little bit more, right? So maybe closer to the 10, and it would kind of balance out a little bit. Does that make sense? That's kind of where we would balance it. That balance is usually closer to where the center is going to be, the true center of the data. You could also think about it in, if there's 50 states, where would be the median? What number would I be at if I was at the median? What state would I be at? The 25th, right? This has 14 in it. This one has 19 in it. So what's 14 plus 19? 14 plus 19 is 33. So that means I've already passed the middle, or the 25th state. So that tells me that my middle is somewhere in this bar right here, somewhere between 5 and 10. Okay, so there's a couple of different ways to find the middle. You can just kind of think of where would the graph balance, or you can kind of find it mathematically by finding where is the median number. Okay, so let's see what the actual answer tells us. This says that the median is in the 5% to less than 7.5%, so that's this one. So it's, yeah, somewhere in this section here, okay? All right, cool. Questions about that? And then what about the spread? What's the spread of this data? Somewhere from 0 to 30-ish, or 0 to 27.5, right? So, I guess we didn't have to answer that. Was that not a question? I don't know. It's fine. All right, so what are we actually doing? Here's a little visual of what we're actually doing. We're taking the dot plot, we're sectioning the dot plot into sections, we're stacking those dots up in those sections, and then we are making them into histogram bars, okay? So that's basically a small little visual of what we're doing from a dot plot to a histogram. Any questions? All right, just like we have done before with dot plots, we can do this with histograms, comparing histograms. So histograms can also be used to compare the distribution of a quantitative variable in two or more groups. And so we can use, histograms can also be used to compare the distribution of a quantitative, it does have to be quantitative, variable in two or more groups. It's a good idea to use relative frequencies, which are percents or proportions, when comparing, especially if the groups have different sizes. So if we have two different groups that have different sizes, we're going to want to use relative frequencies instead of just counts, okay? Be sure to use the same intervals. So we're talking about your x-axis here. Be sure to use the same intervals when making comparative histograms so that the graphs can be drawn using a common horizontal or x-axis. Similar to how we did the back-to-back and they shared stems for the stem plots. Okay? So here's an example for you guys. Is it true that students who graduate from high school earn more money than students who do not graduate from high school? To find out, we took a random sample of 371 U.S. residents age 18 and older from a recent census. The education level and total personal income of each person was recorded. Here are relative frequency histograms of the data for the 57 non-graduates, no, and the 314 graduates, yes. And we're going to compare these distributions. So the high school, whether they were a high school graduate, no. If they did not graduate high school, that's on the top. If they did graduate high school, that's on the bottom. So we want to compare the distributions. What four things do I need to compare? Socks. What does socks stand for? Shape, outlier, center spread. Shape, outlier, center spread. And when you're comparing, make sure that you actually link them. So I'm going to give you guys just a minute to look at that, and then we'll talk about it. Let's go ahead and start looking at this just because I don't want to cut your time short at the end here. So compare your distribution. What did you guys say for shape? Both are skewed to the right. Perfect. Both distributions are skewed to the right. Outliers, what do you think? Yeah, probably 130 and higher-ish,
Okay.
but you don't even really have to say that. You could just say there are some possible high outliers.
Okay.
Yeah, yep. So yeah, the no did not have outliers, but the yes had some possible upper outliers. Centers. So centers. Which one has the higher center? The yes or the no?
No.
So no.
Oh, no.
What do y'all think? The yes or the no has the higher center?
Yes.
The yes. Okay, good. So the yes would have just slightly higher center than the no. The no, like 50% of the data is in that first little section for the no, and so like that the center is in that first section. For here, we would have to go to the second section to get to 50%. So the yes has a higher center than the no. And then the spread, obviously it's very, very obvious. The yes has a wider spread than the no. So, cool? All right. I'm going to give you guys a chance to do this last one, and then you're going to, that way you have no, don't show them the answer. Okay. That way you have a chance to actually make a histogram yourself. So you're going to use this table. This table is the ages of the first 45 U.S. presidents when they took office. And we're going to make a frequency histogram of the data using intervals of width 4 starting at age 40. So it even tells you what to do. So on your x-axis, you should have 40, and then 44, 48, 52. That's going to be your x-axis. And because this is a frequency histogram, what's going to go on your y-axis? Numbers or percentages? The numbers, the counts, or the frequencies. Okay? Once you make your histogram, then you will describe your shape, and then you'll find what percent took office before the age of 60. All right? So I'm going to let you guys work on that. Let me know if you have questions. All right, so let's look at our answers. Here we have a frequency table, and then we have our histogram. Again, we went by 4s on the x-axis, and we have our frequency on our y-axis. And then when we look at the shape of the distribution, it is fairly symmetric and has a single peak in the 52 to 56 range. And then for what percent of presidents took office before the age of 60, we can add up all of the bars that are less than 60. So that's 2, 4, 9, 11, and 8. And that's 34 divided by the 45 total. And that's 75.6% of presidents took office before the age of 60.